Assalamualaikum. Hi, my name is Muhammad Zahir Putra bin Zulkafli and my matrix number is 17DKA24F1038. So, for the objective for CBR is the purpose of determining the CBR value is to evaluate the strength and bearing capacity of the subgrade soil, which is essential for pavement design. The CBR test measure how much pressure the soil can withstand compared to a standard material. This is done by penetrating a plunger into the soil and recording the resistance. The resulting CBR value helps engineer decide the appropriate pavement thickness needed to support traffic loads. A higher CBR indicates stronger soil, while a lower value suggests weaker soil that may need additional reinforcement. So for the apparatus is the first one, cylindrical mold with the inside the diameter 150 mm and height 175 mm, provide with the detachable extension collar 50 mm high and a detachable perforated base plate 10 mm thick. So for the second one is spacer disc 148 mm in diameter and 47.7 mm in height along with handle. The third one is metal rammers, weight 4.89 kg, a drop 450 mm. So for the fourth one is weight, one another metal weight and several slotted weights weighing 2.5 kg each, 147 mm in diameter. So for the the fifth one is loading machine with a capacity of at least 5,000 kg, equipped with a movable head or base that travel at a uniform rate of 1.5 mm per minute, includes a load indicating device. So for the sixth one is metal penetration piston with a diameter of 50 mm and a minimum length of 100 mm. So for the second last is two dial gauge with reading accurate to 0.01 mm. So for the last one is 20 mm IS
Assalamualaikum to everyone. My name is Haris Daniel bin Aris Fazila. My matrix number is 17DKA24F1044. And today I'm going to discuss about data and calculation. First is a table 4.2, data on apparatus item, weight of rammer 4.5 kilo, number of blows 56 times, surcharge weight 4 kilo, diameter on plunger 49.6, area of plunger 19.35. Proving ring conversion factor, number of smallest diff of dia gauge times 1.282. Next is table 4.3, module content data. There is weight container for sample 1 is 16.5, sample 2 is 14.3, sample 3 is 15.2, and the mean for container is 24.45. Next is container plus sample. For sample 1 is 43.0, and next is 41.5, and next is 42.1. And for the mean is 16.74. And the last one is container plus dry sample. The first one is 18.5, 37.6, and 38.0. And the mean is 17.98. And the moisture content is 18.39%. Next, I will continue with data and calculation. There is table 4.4, CBR data log. Penetration, mm, 0.5, 1.0, 1.5, 2.0, 2.5, and so on until 12.5. Proving ring, reading 15, 27, 37, 48, 57, 65, 72, 76, 78, 80, 78, 75, 72, 70, 68, 65, 62, 59, 59, 55, 52, 49, 46, 44, 42, and 40. And load on plunger in kilogram, 19.23, 34.61, 47.43, 61.54, 73.007, 83.33, 62.30, 97.43, 100, 102.056, 100, 96.115, 92.30, 89.74, 87.17, 83.33, 79.48, 75.64, 70.51, 66.66, 62.82, 58.97, and 56.41, 53.84, and last one is 51.28. The last one for data and calculation is the graph of our CBR result analysis. This is our graph that is going up and down. And next is the table 4.5 CBR result analysis. Penetration in nm 2.5, 5.0, and then standard load value PS in kilogram 1370, 2055. And next is load value from graph in kilogram 73.04, 102.56. And this is the formula for CBR, that is PG over PS times 100. And we use the formula, and after that we get the result, that is soil CBR value 5.33%. That's all for me. Thank you.
Hello guys, good morning. My name is Isha Kimi Berushda with number registration 70DK24F1041. Okay, now based on our California bearing ratio or CBR testing, the evaluated soil sample demonstrated a CBR value of 5.33%, classifying it as suitable for subgrade applications, but requiring enhancement for higher structural layers in pavement systems. Results indicate this material meets the minimum requirements for subgrade use, typically under 10% CBR, but falls significantly below the thresholds needed for surface 20 to 30% CBR or base course up to 30% CBR applications. For projects requiring reutilization of this material in more demanding structural layers, we recommend three primary stabilization approaches, which is mechanical stabilization through blending with granular materials like gravel or crushed stone offers a cost-effective solution for moderate improvement. Chemical stabilization using lime, cement, or fly ash additive provides more substantial strength enhancement, particularly valuable for high traffic areas. Additionally, proper drainage implementation and optimized compaction techniques can significantly improve performance by controlling moisture content and increasing density. This stabilization method should be evaluated through laboratory trials to determine the most effective and economical solution for the specific project requirements. The selection criteria should consider traffic load expectations, environmental conditions, and project budget constraints. Implementation of these recommendations will transform the existing subgrade material into a suitable component for higher pavement layers while maintaining long-term durability and performance.
For second discussion is CBR test result play a critical role in the design of pavement thickness. This value help engineer determine the appropriate thickness of each pavement layer to ensure it can effectively distribute traffic load to the subgrade without causing failure. A higher CBR value allow for a thinner pavement structure while a lower CBR requires a thickness layer to compensate for the weak support. It is essential to perform both soak and unsoak CBR tests to simulate real-world condition accurately. The unsoaked tests represent dry condition which might not reflect the actual site situation, especially during rainy season. In contrast, the soak test simulate the worst case scenario where the soil is saturated with water, which often reduce its strength. By comparing both results, engineer can design more durable and reliable pavement that perform well under varying moisture condition, reducing maintenance need and extending the lifespan of the roads. So that's all. Lastly, for the conclusion is, based on the CBR test result, the test soil may only be suitable as subgrade material unless it meets higher CBR value through improvement technique. The CBR test is a fundamental tool in pavement design, influencing layer thickness and durability. Conducting both soaked and unsoaked tests ensure the road structure are resilient under varying moisture conditions.